Steve here with SSI. Thanks for tuning in. Today's episode we're going to cover a little bit about using a pneumatic for a hydraulic. I have an old horizontal bandsaw that I need to put a descent feed system on that uses a hydraulic cylinder. Hydraulic cylinders are fairly expensive, so I'm going to use a pneumatic cylinder converted over to hydraulics. I hope you like the episode so far. I have upgraded the camera and the microphone, so hopefully you can hear and see me better. We cover a lot of different topics on this show. I'm going to keep doing so. You can check out my Facebook page under Stephen Prenger, S-T-E-P-H-E-N, or you can follow the link posted above on the YouTube channel. So here we are at the horizontal bandsaw. I've already installed a pneumatic / hydraulic to use for the feed for this system, for this saw. You just let off the valve just a little bit and the saw will feed on its own. The problem that a lot of these systems have is they get air in the system, so it allows a little bit of movement, just like this one. You don't want movement too much in the cutting because it'll start to get the saw to bounce and shake. So I want to remove the air from the system. I've used this system for a while. It works really well. But I want to change this around a little bit, and I want to add a reservoir. That will keep the air out of the system, and for future leaks it'll help you in an aspect that you can refill it very easily, and it'll automatically purge the system for you, just like the hydraulic pump in your car, which is called the power steering system. I've already made the brackets and I've installed the piece as it is, but I want to go ahead and change it around. I want to change this piece, and I want to add a reservoir to the back side of this. This is the reservoir I'm going to use. It already has an 1/8 inch national pipe thread added to it. I drilled a little hole on top of the cap to let air in and out of the reservoir as needed, so it doesn't vacuum lock. This is the tubing I'm going to use, which is a nylon reinforced brake tubing. It's flexible because this piece moves up and down with the saw. It's not a whole lot of movement, but you can tell it does move some up and down. So I want to try and keep the reservoir up high and just route it in. That way whenever that moves, that hose will flex with it. It shouldn't be an issue. Now you don't have to use this nylon tubing for the reservoir. It can be any kind of tubing as long as it will withstand what you're using for your hydraulic fluid. It can be rubber, it can be anything. I'm going to use it because that's what I have in place, and I've got to replace this piece anyway, so I might as well just use it for both sections. It'll never wear out and it should never give me any problems. So I'll get that taken care of. We'll get the bracket installed before we come back, but I'll get it apart, get it on the bench, and show you how to put it together. Okay, so here's the system as it is. You have your shut-off valve, which is just a needle valve that you can crack open to let fluid pass from one side of the cylinder to the other. You can get a control valve that has a check ball in it, so one direction of fluid movement is restricted, so your ram will slide in and out slowly and you can control the feed, and the other direction of movement, fluid passes freely, so you can just pick up the saw and let it drop right back to the same feed rate that you had before without ever having to mess with this. I'm not going to use that system, mainly because the valve's $30. I don't really want to bother with it, and I'm only cutting pieces here and there. So I use the saw all the time, but I don't do a lot of cutting with it in a row or for production purposes. So I can adjust the needle valve per cut. If I've got to make 5 or 6 cuts, it's not that big a deal to me. But I have to remove everything from this end over. Okay, I've done some digging around, and I just happen to have a couple of these little fittings here. These are 1/8 inch national pipe thread, and they do have the barbed ends on it for hose. So I guess I will go ahead and use just standard rubber hose for the reservoir coming out the back of this particular item. I wasn't going to at first because I thought it might look neater, but just to show you that it can be done with it, I'm going to go ahead and do it. Now, one thing that's nice about using a reservoir with this system, even though it's not going to be that much of an issue with me, is this ram, when it's moved all the way back to the far position, that's how much extra fluid is in the system when it's closed loop like this. So it doesn't allow the ram to go all the way back. Now, if you're using a reservoir, you can push the extra fluid back up into the reservoir and allow for full movement of the ram. And you can still see how much little bit of air is left in there. Now, when I did this system originally, this little plug right here was removed, and I screwed on a reservoir and pumped the ram back and forth to get rid of all the air that was in the system originally. It worked, and apparently it has lost some fluid somewhere. It might have been around one of these fittings. I think it's around this one if it is. This really isn't the proper fitting between the T and the pneumatic. A little bit of residue has been on the ram a time or two, but it's nothing real major. I mean, there's no spot in the floor, anything of that nature, so whatever it's losing, it's very, very little. And when I put the reservoir on, filling it and keeping it full won't be a problem. So I'll get this stuff taken off and show you what I'm going to do. Okay, I'm getting ready to reassemble this. I want to show you a couple of things. The reason I've replaced a few items. This was the tubing that was in between the two pieces that was originally here. Well, one end of this did real well. I got a little bit past the compression fitting. On this side, I did not quite have enough tubing to make it past the compression fitting. So I'm going to go ahead and just replace this tube and make it a better length. I had to cut it in half because I had to get these things back. The other part of the compression fitting. So I have the T. Originally the T was positioned like this. This top section had this little plug in the top of it, so I could screw in a temporary reservoir when I needed to bleed the system. Since it's going to be permanent, I don't need that anymore. So this piece will be on the back of this now. It'll be positioned like so. This back half will have this fitting on it, which is the barbed fitting for the hose. And one of the reasons I think I had a leak here at this end was this particular fitting right here. This is mainly a connector, so you have a piece like this screwed into here with the other half of the compression fitting over the top of it. It connects the two tubes. Well, that's not what's supposed to be in there. It's supposed to be like this. You see the difference between the threading. This is 1/8 inch national pipe thread. This is whatever thread they use for the compression fitting. So it wasn't correct, but it did work for the time being. And yes, it did leak. Well, after further investigation, I've noticed that I did change this valve or the fitting from this side over to this side. The reason why is whenever the saw is in motion in the downward stroke, this ram is getting pulled away. So all the fluid's going from this side out over to this side. Well, I had the T over here originally, and if that was going to be the case, so when it came out it was just going to go straight out into the reservoir, and there wasn't going to be any way to regulate its travel, so the feed wouldn't be able to be adjusted. So I'm going to take fitting from this end and put it over here, and I'm actually going to put my reservoir on this side of the saw now. We're all here back at the saw, getting ready to make a cut, but I wanted to show you how this thing finally went together. Instead of using the little black can I had earlier, I've switched over to this plastic bottle so you can see exactly what's going on inside. So we have the 90-degree into the high pressure hose, because as the saw comes down, the rod goes out, pushing fluid from this side over to the valve and out to the reservoir. When the saw is in the upright position, all the fluid will move straight from this end out into the reservoir. That's the extra stuff that's not needed. Break the valve loose. Tighten the valve up. Let the saw rest up against the fluid inside. And you can just crack it. That lets the saw descent in a controlled manner. Now I have a part in here that I'm going to cut to show you. And I'm going to go ahead and get it set up for the cut. Alright, I'm going to set my feed rate when the saw comes on. Well, let's talk about hydraulic fluid for a second. Now, the hydraulic fluid I used for this particular application was standard old baby oil. It's actually a mineral oil with some perfumes added to make baby smell good. That's all baby oil is. You can use any kind of hydraulic fluid you'd like. Automatic transmission fluid would probably work. I would probably stay away from things that had a lot of friction modifiers in it, or grit. You can also use brake fluid is a good hydraulic fluid. Power steering fluid is a good hydraulic fluid, because that's pretty much what they are. But for this application, baby oil is what I used. It seems to work out real well. What you have to really stay away from are thicker oils that can't be pushed through those small 3/16 tubes very well. I've used motor oil in the past, just a straight 30 weight motor oil. That seemed to work okay, but it was so hard to pull through the tubes that sometimes it would, if the reservoir isn't deep enough, you can pull air through the oil and straight into the hydraulic or the pneumatic that you're using. Thanks for watching this episode. I hope you enjoyed it. In no way do I endorse using pneumatics to ever replace a hydraulic cylinder. Hydraulics withstand much more pressures than pneumatics do, anywhere between 1500 and 3000 psi. So if you replace a pneumatic cylinder or if you put a pneumatic cylinder in the place of a hydraulic cylinder, more than likely catastrophic failure will occur and may be fatal. The pneumatic cylinder I used in this particular video is a stainless steel body construction with aluminum ends that are threaded in. All the fittings are brass, 1/8 inch national pipe thread, and can be found at a local hardware store. And check out more of my videos on YouTube, plus you can find me on Facebook under STEPHEN Pranger, Pranger. Go there, check me out, and give me a like or a thumbs up. Same with this video. Please subscribe if you like what you're seeing so far. Thanks for watching.